Okay, this lesson is on chapter 7.3, how to prove a given quadrilateral is a parallelogram. You don't need to write all of these things down. They're going to be printed on your worksheet. I'll tell you when you want to start writing. But let's talk about first, how can you prove a shape is a parallelogram? So the first way we have here is to show that the opposite sides are parallel, and you do that showing that they have the same slope. So you're just going to look at the rise over run, or you might need to use the slope formula, y2 minus y1 over x2 minus x1, and you'll do that for the opposite sides. You'll want to show these two are parallel, and then you'll want to show that these two are also parallel. That's one way. The second way to show something is a parallelogram is to show that the opposite sides are congruent. Now, in order to do this, we'll need to find their lengths using either the distance formula or the Pythagorean theorem. You know I'm a fan of the Pythagorean theorem whenever it's possible, and in order to do that, if we want to find the length of this side, we just make it a right triangle, and we use these two sides for our legs, and then we use the side we're looking for C. The third way is to show that the opposite angles are congruent. We won't use this one a lot. In general, you would do that if you had the opposite angles marked as congruent, then that would be helpful. Let's see, let me get rid of all of that. Put in a new parallelogram for us. Okay. So the fourth way is to show that one pair of opposite sides are both parallel and congruent. So for this one, you're going to pick one set of sides. Say we pick the long sides, and we're going to want to show first of all that they're parallel. So we would do that by finding the slopes. And then we also want to show that they're congruent, and we would do that finding the lengths. We don't have to show anything about the other two sides if we can show that that one pair has both the congruence and they're parallel. That's the fourth one. The fifth one is to show that the diagonals bisect each other. We learned in the last lesson that parallelograms have diagonals that bisect each other, and that meant that they had the same midpoint. So if we find the midpoint of this segment being here, and then we found the midpoint of this segment, and they were both in the same spot, then that would show that it was a parallelogram because their diagonals bisect each other. So those are the 5 ways that we're going to use, and we're going to practice those 5 ways. So let's see. Okay, the first method we're going to practice is to show that the opposite sides are parallel by showing that they have the same slope. So when you're doing this, this is the way you want to show your work. You want to show that you have opposite sides A, B, and DC. You have opposite sides A, B, and CD. Don't just write down fractions and expect someone else to know what you're talking about. Be sure that you write down what it is you're looking for. So to find the slope of AB, we're just going to do rise over run. So it's up 1 over 3. It's a positive slope of 1/3. And then we do the same for DC. It's rise 1 and run 3. So it also has a slope of positive 1/3. So we've shown that those two are parallel. And then we're going to do the same thing for AD and BC. Now AD and BC both have a negative slope. And let's see, the rise and the run, it's down 4 over 2, so negative 4 over 2, which we would simplify to just negative 2. Same thing for BC, down 4 over 2, so negative 4 over 2, which is going to be negative 2. And then you would write out a statement saying, since the opposite sides have the same slope, or same slopes, they are parallel. And then just to be a little bit more specific, we're going to say AB is parallel to DC and AD is parallel to BC. So that's method 1. Method 2 is to show the opposite sides are congruent by finding their lengths, using the distance formula or the Pythagorean theorem, I'm going to use the Pythagorean theorem. So first I'm going to find the length of AB. And we're going to make that right triangle. That's up 4 and over. So this has a length of 4 and this one has a length of 1. So we're going to say 4 squared plus 1 squared. And we know we need to take the square root of that. So remember, we're going from c squared is equal to a squared plus b squared. So c is equal to the square root of a squared plus b squared. Remember, in your order of operations, you've got to do a squared plus b squared first, and then you can take the square root of the sum. So we're going to do the square root of 16 plus 1, so that's the square root of 17. It's perfectly fine to leave this AB is equal to the square root of 17. There's no need to change that to a decimal. Now the opposite side for AB is CD. So if we make a right triangle again, we see that the length of this leg is 4 and the length of this leg is 1. I know if you see that, you ought to be able to tell, okay, the hypotenuse is still going to be the same. But for now, I want you to go ahead and show me the work for that so I can see what your thought process is. We're still doing 4 squared plus 1 squared. And just go ahead and take the time to write it out. 16 plus 1, square root of 17. So CD is also equal to the square root of 17. So that shows those two are the same length. Then we're going to do the same thing. Let me switch colors for this one. We'll do BC. And so this is a rise of 2. So that leg is 2. And it's kind of like you're using the slope to make that triangle, right? Even though we're not actually looking for the slope. So the legs are 5 and 2. So for the length of BC, we're going to do this 5 squared plus 2 squared. So that's going to be 25 plus 4. That's the square root of 29. So BC has a length of the square root of 29. We'll do the same thing. Our last one is going to be for AD. So this is 2, and this side over here is 5. So for AD, we're going to do 5 squared plus 2 squared again. AD is equal to the square root of 29. And then underneath there, you can make a statement about how since the length of AB and CD are both the square root of 17, and the length of BC and AD are both the square root of 29, the opposite sides are congruent, and that's going to make it a parallelogram. Okay, now we went over the one on angles, and we've gone to option 4, which is to show that one pair, so you're going to pick one side, one set of sides, and show that they're both congruent and parallel. I'm going to use AB and CD. So first I'm going to find their slopes. So the slope of AB and the slope of CD. And I'm just going to do rise over run. So rise 1, run 1, and that's a positive slope of 1. For CD, rise 1, run 1, positive slope of 1. So this tells me that AB is parallel to CD. And then I want to find their lengths. Lengths. So AB, we're going to do the square root of, we have that little triangle already ready for us. So our legs are a 1 and a 1. So 1 squared plus 1 squared. That's going to be 1 plus 1. So AB has a length of the square root of 2. And then for CD, those legs are also a 1 and a 1. Length of 1 and a length of 1. So 1 squared plus 1 squared. So since AB and CD both have a length of the square root of 2, we know that AB is congruent to CD. And that's going to make it a parallelogram. All right, the last one we're going to do here is we're going to use option 5, which is to show that the diagonals bisect each other by showing they have the same midpoint. So we need to find the midpoint. Remember that we're talking now about the diagonals. So we're not talking about the sides anymore. We're talking about diagonal AC and, let's see, diagonal BD. So let's find the midpoint of BD by using our midpoint formula, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Remember, this is giving us an ordered pair because we're just looking for the midpoint. So B, we need those ordered pairs. So B is over 3 and up 1, 2, 3, 4, 5. So B is 3, 5, and D is -3, -2. So we're going to add our x's. So -3 plus 3 divided by 2. And we're going to add our y's, -2 plus 5 divided by 2. So 0 divided by 2 and 3 divided by 2. So 0, 1 and 1/2, or you can leave it 3/2 if you want. Either way is fine. Now we're going to find the midpoint of AC by using those ordered pairs. C is 1, 1, and A is -1, +2. So we're going to add our x's together, -1 plus 1 divided by 2. Add our y's together, 2 plus 1 divided by 2. We get 0 divided by 2, and 3 divided by 2, which gives us 0 and 1.5. Since these two have the same midpoint, that must mean that they bisect each other, which means that this side and this side are equal to each other, and that this side of the diagonal and this side of the diagonal are equal to each other. And that's how we prove something is a parallelogram. We use any of those methods on your worksheet. I'm going to ask you to practice using each one. Let me know if you need any help.